Welcome back to the deep dive. I actually want to start today by tapping into a very specific feeling.
Oh boy.
Yeah, I think anyone who has ever written a line of code or, managed a server knows this exact feeling. It is 4:00 p.m. on a Thursday. You have been wrestling with this microservice for like 3 days straight,
Right, you're fighting firewalls, fighting dependency errors,
fighting your own will to live, honestly.
the absolute dark night of the soul phase of software development.
Exactly. But then you change one single line of config, you hit deploy, the terminal spins, and suddenly you get that beautiful green text.
Deployment successful.
Yes, you curl the endpoint and you get a 200 OP. The data is flowing. It actually works.
It's basically the single best dopamine hit in the entire industry. I mean, it's why we do what we do.
It really is. But today, we're going to talk about the hangover that comes immediately after that dopamine hit.
Yes. The hangover.
Because sometimes the exact thing you did to make it work is the thing that leaves the front door wide open. You built a system that functions perfectly, but security-wise, it is a ticking time bomb.
We call this the it works trap. And
Yeah.
specifically today, we're talking about the absolute most common shortcut in cloud computing, which is how we handle passwords.
Right, so we are diving into a really sharp article today from the Tech Reader blog. It's specifically part 45 from their Secret Life of AWS series.
Titled The Plaintext Password.
Yeah, and what I love about this piece is that it's written as a narrative. It follows these two characters. You have Timothy, who is a developer who just wants to ship his code, and Margaret.
Margaret is the security engineer who, unfortunately, has to be the bearer of bad news.
Always a fun job. And the mission of this deep dive isn't just to sit here and say, hey, don't write passwords on sticky notes.
Right, everyone knows that by now, hopefully.
Hopefully. The goal here is to really understand why the standard best practices from, say, 5 years ago, like environment variables, are actually dangerous in a modern cloud context.
And then we need to map out the modern solution, a system that is dynamic, automated, and self-healing.
So let's set the stage with Timothy. He has built an inventory microservice on AWS Lambda. His job is pretty simple on paper. Just get this service to talk to a checkout database.
Right.
Now, give us the lay of the land here. Is Timothy just a sloppy developer?
Not at all.
Yeah.
That is the really important part to understand. If you look at his infrastructure, it is rock solid.
Yeah, the source says he's using an AWS Transit Gateway.
Exactly. The Lambda is sitting inside a private VPC. The database is in a private subnet. There is zero public internet access.
So the network architecture is great.
If you were drawing this on a whiteboard, you would give him an A+.
Okay, so the pipes are secure, but then he runs into the inevitable problem. The Lambda function still needs to log into the database.
Right. It needs a username and a password.
Okay.
This is the authentication layer.
Right.
The network allows the connection to happen, but the database is still standing there asking, who are you?
So Timothy does what I think 90% of tutorials do. And honestly, probably half the people listening right now do this.
Oh, absolutely.
He goes to the AWS console, clicks on his Lambda function, scrolls down to that section nicely labeled environment variables, and he just types in dbhost, dbuser, and dbpass.
And for the password, the article notes he uses super secret database password 123 exclamation point.
A true classic. So he types that in, hits save, deploys it, and it works.
Boom. Dopamine hit.
Exactly. But then Margaret, our security hero, walks by. She looks at his screen and essentially hits the emergency stop button on the whole operation.
She does.
Now, here's where it gets super interesting because Timothy defends himself. He says, look, Margaret, chill out. I didn't hard code it in the Git repository.
Right.
He says it's an environment variable. It is injected at runtime. This is a standard 12-factor at best practice.
And, he is not wrong, historically speaking. Like 10 years ago, the big cardinal sin was committing password equals 12345 directly into your main.py file.
And pushing it straight to GitHub.
Exactly. So moving that to an environment variable was the big solution back then. It separated the config from the code.
So why is Margaret freaking out then? If it is not in the code, where is the actual risk?
The risk is that while it's not in the code, it is in the configuration. And in AWS Lambda, environment variables are stored as plain text.
Wow, plain text.
Well, technically AWS encrypts them at rest under the hood, but, and this is the absolute kicker, as soon as you open the console to view the configuration, they're decrypted and displayed right there on the screen for you.
So literally anyone who can look at the settings can see the password.
Exactly. And we really need to think about who that anyone is in a corporate environment. It is not just some shadowy hacker who breached your account.
Right, think about your internal permissions. You might have a junior developer or a support engineer, maybe an SRE.
Exactly.
Yeah.
Someone who gets paged at 3:00 a.m. because the function is timing out and they need to debug it.
And to do that, they need an IAM permission, right?
Yes, a permission called Lambda get function configuration.
Get function configuration.
Right. It allows them to see how much memory is allocated, what the timeout is set to, what layers are attached. It sounds like a totally harmless read-only permission.
But because the environment variables are part of that configuration block?
The API returns the entire configuration.
Oh, man.
So your support engineer, who is really just trying to bump the memory from 128 megabytes to 256, is suddenly staring at the master root password for your production database.
In plain text?
In plain text. So
Right.
Timothy has effectively given admin database access to anyone who has basic read access to the Lambda console.
That is just a massive escalation of privilege. It's like giving the janitor the keys to the bank vault just so they can check the thermostat in the lobby.
That is a perfect analogy. And Margaret's verdict in the story is brutal, but totally accurate. She tells him, Timothy, you have decoupled the secret from the code, but you have not secured the secret.
Decoupling is not securing. I feel like we should put that on a t-shirt for reInvent this year.
I buy it.
So Timothy effectively just has a digital sticky note slapped on his server rack.
Correct. So Margaret sits him down and says, we need to delete that environment variable right now. We need a completely new architecture.
And she opens up a different service, AWS Secrets Manager.
Yes.
Now, I have seen people get really confused here because AWS has a lot of services that sound very similar. There is Systems Manager Parameter Store, and then there is Secrets Manager. Margaret specifically chooses Secrets Manager. Why is that?
It really comes down to specialization. Parameter store is basically a general purpose locker. Now, you can put anything in there, a URL, a random setting, a string.
Okay.
But Secrets Manager is a bank vault that is specifically designed for credentials. When Margaret clicks store a new secret, she isn't just given a blank text box.
Right. She selects credentials for Amazon RDS database.
Exactly. So the tool actually understands what it is storing. It understands the schema. It specifically asks for the username, the password, the engine, the port.
It's structured data.
It is. Margaret fills it in, selects the specific checkout database instance from a drop-down list to link them together, and gives it a very clean name like prod/checkout/db credentials.
Okay, so she hits save. What actually happens to that data? How is this fundamentally different from just typing it into that text box in the Lambda console?
This is where we get into envelope encryption. When she saves that secret, AWS uses the Key Management Service, or KMS, to encrypt that data with a specific encryption key.
Meaning it gets entirely scrambled.
Scrambled, yes.
Huh.
But more importantly, access to the secret itself is now completely separate from access to the key.
Oh, I see.
Even if I have permission to list the secrets and I can see that prod checkout DB credentials exists, so I can see the metadata, I cannot see the value inside.
Unless you also have explicit permission to use that KMS encryption key to decrypt it.
Precisely.
It's a dual lock system. In the Lambda console, one key basically opened everything. But here you need the key to get into the room and then a totally separate key to open the safe.
That's exactly how it works.
Okay, so the password is safe in the vault now. Timothy deletes the environment variable. But now he has a very practical, immediate problem. His code is crashing.
Right. Because the Lambda function wakes up, checks its pockets for DBPSS, and finds absolutely nothing. The variable is gone.
So how do we bridge that gap?
This is the major shift from static configuration to dynamic retrieval. In the old way, the password was just sitting there when the app started.
Right.
In this new way, the app actually has to actively ask for it.
So Timothy has to rewrite his code.
He does. He has to import the AWS SDK, the software development kit, and inside his initialization code, he writes a function that essentially says, hello, AWS Secrets Manager, please give me the value for prod checkout DB credentials.
And assuming the permissions are set up right, which I know we are going to get to in a second, Secrets Manager decrypts it and just hands it back.
It hands it back directly into the function's memory, and this is a super crucial security detail here. The password never touches the disk.
It's never written to a local config file.
Never. It exists in the volatile memory of the function, only for the handful of milliseconds required to open that database connection.
That sounds incredibly secure. Honestly, it does. But I can already hear the performance engineers listening to this, and they are starting to sweat.
Oh yeah. Latency.
Timothy brings this up in the blog post, too. He says, wait a minute, I have a high traffic store. If I am processing 10,000 orders an hour, am I really making a network call to Secrets Manager 10,000 times?
That is the big fear.
Yeah.
Because network calls introduce latency. If every single time a user clicks by, your app has to pause, call AWS, wait for a response, decrypt the payload,
Your app is going to be painfully slow.
slow and very expensive.
Right, because AWS charges you for those API calls.
Exactly. So if you implement this lazily, you will absolutely have a slow, expensive application.
So what is the fix then? Because Lambda is stateless, right? It spins up, runs the code, and then it dies. How do you possibly keep the password around without writing it to disk?
Well, see, that is a very common misconception. Lambda isn't totally stateless. And understanding this nuance is really what separates the junior cloud devs from the senior architects.
Okay, break that down for us.
When a Lambda function runs, AWS spins up a microcontainer. They call it an execution environment.
Right.
That container processes the request. But when the request is done, AWS doesn't actually kill the container immediately. It keeps it warm for a few minutes, anticipating that another request might come in soon.
Ah, the famous warm start.
Exactly. So Margaret explains to Timothy that he just needs to write his code to leverage this feature.
Mm.
He puts the code that calls Secrets Manager outside of the main handler function.
He puts it in the global scope.
Correct. When the container first boots up, which is the cold start, it pays the latency tax. It calls Secrets Manager, gets the password, and assigns it to a global variable.
And that takes, what, maybe 200 milliseconds?
Roughly, yeah.
But then the container stays alive.
The container stays alive. So when the next 10,000 requests come streaming in, the handler function just grabs that variable directly from the global memory. It is instant.
It is essentially caching it in the backpack of the function.
Exactly. You pay the cost once, and you reuse it for the entire lifetime of that container. So you get the heavy security of the vault, but you keep the speed of a hard-coded variable.
That is really smart. Okay, so we have solved the speed issue. Now let's circle back to that junior dev or support engineer scenario we talked about earlier.
Right, the internal threat.
Yeah. In the old world, if they looked at the configuration, they saw the plaintext password. In this new world, if they look at Timothy's code, what do they actually see?
They just see a line of code that says get secret value, prod checkout DB credentials. They just see the name of the secret,
But not the value itself.
not the value.
But hold on, let me play devil's advocate here for a second. If I am that junior dev and I can see that code in the repo, couldn't I just copy that code, run it on my local laptop, and get the password that way?
That is a very smart question.
Right.
And the answer is a hard no. This brings us right to IAM, Identity and Access Management.
How does IAM actually stop me there?
Because in AWS, identity is completely decoupled from the code. When the code runs inside Lambda, it adopts the identity of the Lambda execution role.
Okay.
So Margaret attaches a policy to that specific role that says, allow Secrets Manager get secret value.
Right.
But, and this is the critical part,
Yeah.
she scopes that permission strictly to the Amazon resource name, the ARN, of that one specific secret.
So the Lambda function basically has an ID badge that lets it into the vault.
Right. But you, the junior dev, running that exact same code on your laptop, you are using your own personal IAM user identity.
Oh, I see.
And unless an admin explicitly gave you, the user, permission to access that specific secret, AWS will just reject the request. Access denied.
So even though I literally have the exact code and I know the exact name of the secret, I still cannot get the password.
Exactly. The code is just a set of instructions. Without the proper identity backing it up, the instructions are useless.
That is a massive improvement. You have successfully blocked that whole support engineer vulnerability.
We have.
But there is always a trade-off in the cloud, right?
Yeah.
We have to talk about the bill.
The bill always comes due.
Timothy looks at the AWS pricing page. Secrets Manager costs 40 cents per secret per month, plus a small fee for the API calls.
Correct. 40 cents.
Now, 40 cents sounds like absolutely nothing. I probably have 40 cents in my couch cushions right now. But if you are an enterprise and you have tons of microservices and each service has a dev, staging, QA, and prod environment.
It scales up fast. Suddenly you have 5,000 secrets.
Right. That is $2,000 a month just to store passwords.
It definitely adds up.
So Timothy asks the completely obvious question here. Why not just use parameter store? That other service we mentioned earlier, it is completely free for standard parameters. Why on earth would I pay the 40-cent premium?
This is where Margaret drops the hammer in the story.
Yeah.
She totally acknowledges that parameter store is great for things like a weather API key or a simple feature toggle setting.
Sure.
But for core database credentials, she insists on the 40-cent option.
Why? What is the killer feature that is worth 40 cents a month?
One word: rotation.
Automated rotation. Okay, let's unpack this because I think this is a term that everyone throws around in meetings, but very few people actually understand the mechanics of it.
It's the thing we all know we should be doing, but nobody actually does.
Yeah.
Margaret asks Timothy a question that makes literally every developer cringe. She says, "How often do you change that database password?"
And Timothy says, never.
Never. Because think about the manual process of doing that. You want to change a database password, you have to log into the database as an admin and change it. Great. But now your app is broken.
Right, the app is still happily trying to use the old password and failing.
So you have to rush to update the app config. You have to redeploy the app. And you have to do this for every single service that talks to that database.
You have to coordinate this massive simultaneous update across your whole stack.
It is an orchestrated crash waiting to happen. So what do we do in reality? We just don't change the password. We let it sit there for 3 years.
Which is an insane security risk. If that password leaks on day one, it is valid forever.
Exactly.
So how does Secrets Manager actually handle this? How does it justify that cost?
It automates the entire nightmare. You just flip a switch in the console that says rotate every 30 days. When that day comes, Secrets Manager doesn't just change the text in the vault. It actually performs a coordinated maneuver.
Walk us through the steps of that maneuver. It's Tuesday, it's rotation day. What actually happens?
Secrets Manager spins up a dedicated rotation lambda. This is a special worker function, and it goes through 4 steps.
Okay, step 1.
Step 1, it logs into the database using the current working credentials, and it creates a new version of the password, a brand new user or password string.
Okay, so now the database has a new password pending.
Step 2, it tests it. The rotation lambda actually tries to log in with the new password just to make sure it really works.
That is smart. Don't commit to it until you verify it works.
Exactly. Step 3, it updates the secret value inside the Secrets Manager vault. It essentially moves the label AWS current from the old password to the new one.
And step 4.
It finalizes the process. And because Timothy's application is using that dynamic retrieval method we talked about, because it asks for the secret every time the cache expires, the application automatically picks up the new password.
Without a deployment.
0 code changes. 0 deployments. 0 downtime. Timothy is asleep in his bed. The robot wakes up, changes the password of the database, updates the vault, checks that it works, and goes back to sleep.
And the application never even notices a thing.
It just keeps humming along. That is the fundamental difference between storage and management. Parameter stores data. Secrets Manager manages the entire life cycle of the credential.
That makes a lot of sense. And Timothy asks a really good what-if question in the blog post here. He asks, what if the rotation script fails? Like, what if the database is busy and rejects the password change? Does it corrupt my credentials?
Yeah, do I get completely locked out of my own app?
Right.
No. Because of that, step 2, the testing phase. If the test fails for any reason, Secrets Manager just aborts the rotation. It leaves the old password as AWS current.
Oh, that's great.
It sends an alarm to the admin, obviously, but the application keeps running smoothly on the old password. It fails safe.
That is incredibly robust.
It really is. It transforms credential management from a terrifying manual chore into just a reliable, background, automated process.
So by the end of the story, Timothy is a total convert.
He is. He deletes those plaintext environment variables, which I imagine felt very satisfying.
Yeah.
He updates his code to use the SDK.
Yeah.
And he sets up the 30-day rotation schedule.
And the article summarizes the final state so beautifully. It says, the network was private, the identity was scoped, and now the credentials were secure.
It is a very clean, very mature architecture.
I want to zoom out for a second before we wrap up today. We started this deep dive talking about the it works trap. The reason Timothy used environment variables in the first place wasn't because he is bad at his job. It is because it was the path of least resistance.
Resistance is the key word there. Security usually adds friction. It adds complexity. You have to write more code. You have to configure IAM policies. You have to set up KMS keys. It is just more work.
But what is so fascinating here is that once you get over that initial hump of setting up Secrets Manager, the friction actually goes down.
That is the big paradox. Manual password management, the sticky note method, is super low friction to store, but incredibly high friction to maintain. You dread the day you have to manually rotate it.
Yeah.
Automated security is high friction to set up, sure. Maybe it takes you an afternoon. But it is 0 friction to maintain.
You are front-loading the pain to basically buy yourself peace of mind forever.
And you are completely removing the human element. We often think of security as building stronger walls. But in this case, it is really about building a robot gatekeeper. The robot doesn't get lazy. The robot doesn't forget to rotate the password because it is a Friday and it wants to go to the pub. The robot doesn't accidentally copy-paste the production password into a public Slack channel.
It just removes the inherent fragility of human behavior from your critical path.
Exactly.
Yeah.
And that is exactly where the industry is going. Security by design, not security by policy.
So here is the thought I want to leave you with today as we close out. We looked at a very specific case today, database passwords in AWS, but this core concept, dynamic retrieval versus static configuration, it applies everywhere.
It really does. API keys for Stripe, access tokens for Slack bots, TLS encryption certificates.
Right. So I want you to look at your own infrastructure. Look at your own code bases. Where are your digital sticky notes? Where are you relying on a static value simply because you do not trust the automation to handle it? Or maybe because you think setting it up is just too much work.
Because if a machine can safely change its own password every 30 days without breaking the app, what other manual tasks are you clinging to that could easily be handed over to the robots?
That is the question to ask yourself. Go check your IAM policies, go rotate your secrets, or better yet, let the robot do it for you. Thanks for joining us on this deep dive, and we will catch you on the next one.